Okay, guys, let's start about the mutual induction. So the mutual induction, if you can take a look here, okay, here, guys, if you can take a look here, the ability of one coil to induce this one, guys, the ability of one coil to induce voltage into another coil is called mutual induction. Okay, and the amount of the voltage induced in the secondary coil or in the secondary part is determined by the number of turn of wire in the secondary as compared to the primary. Okay, guys, so here, if you can take a look for this page, if you can take a look here, page 325 here, guys, if you can take a look this page, for example, this one, guys, this is the AC volt. I can see this is 120 volt AC. Okay, and here the turn here is 240 turn. Okay, so 240 turn. This one, guys, this is the primary side. Okay, and here there is a load. You can see this one load, and here, guys, here is 100 turn. Okay, so here, guys, the here the primary winding. Okay, here you can see here the primary winding is this one, guys, will produce magnetic field. You can see there is a magnetic field here. This magnetic field will cut the secondary winding. This is the secondary winding. Okay, and this will produce induce voltage. Okay, here it will produce the induced voltage, and the ability for the coil to produce induced voltage is called a mutual induction. And the amount of the voltage here, the induced voltage in the secondary is determined by the number of turn of wire is in the secondary compared with the primary. Okay, so if we have here, for example, guys, if we have here 120 volt. Okay, so if we want to solve the problem, for example, if we have 120 and we have here 240 turn and 120 turn, so how can we solve the problem for to know the voltage in the secondary winding? Okay, so to solve the problem, so we have to know the voltage per turn ratio. Okay, okay, guys, for example, in the primary, we know that the voltage per turn ratio is equal 120 volt divided by 240 turns. Okay, this one will equal 0.5 volt per turns. Okay, guys, and the secondary part or secondary side, so this one, guys, this is in the primary, which is here 120 divided by 240, this will equal 0.5. And the secondary part, you can see the secondary part is also voltage. We have to know the voltage in the secondary, part divided by this one here. We have 100 turns. What equal the same, 0.5, the same. 0.5. Okay, and then we can know the voltage in the secondary. This is voltage in the secondary side. We can know the voltage in the secondary side equal 100 times 0.5, which equals 50 volts. Okay, guys. Okay, guys. In the example number one, if you can take a look about the example number one, the same in the figure 13 2. I don't know if you can take a look to the figure 13.2. 13.2. Honestly, it is similar to this figure. It is very similar to this figure, which is the same. But here he told you about that uh, 240 turn of wire in the primary and 60 of turn in the wire in the secondary. Okay, guys. So here the wire we have to you have to know this formula. The voltage in the primary divided by the voltage in the secondary equal the turn in the primary divided by number of turn in the secondary. So we know the turn in the primary. He told you that it is equal to 40. So we can, so this one, guys, this one, okay. So here, this is a primary. This NP is a primary turn of wire, and a secondary turn of wire. EP is the primary voltage, and ES is secondary voltage. So NP primary turn of wire, he told us is equal to 40. So I'm gonna write 240 here. And secondary is 60. So the number of secondary is 60. Okay, and he told that 120 volt is connected to primary winding. You can see here 120 volt. This one, the primary voltage here, he puts 120, and we have to find the voltage in the secondary winding. So this one, guys, ES equal the voltage in the secondary winding. Okay, guys. Secondary winding. Okay, guys. So here you can see this is 30, and the primary voltage it is 120. Okay, this means this transformer this is 30, and the primary voltage is it is 120, and the secondary voltage is 30. That means this transformer is step down. You can see the voltage right now is less. That means the transformer it is step down because it has lower secondary voltage than the primary voltage. Okay, if I ask you what is the kind of the transformer, you have to tell this one step down because secondary voltage 30 is less than the primary voltage 120. Okay, so if we have, for example, you can see in this example here, we have, if we have, for example, here uh, impedance. Okay, we have, for example, here we have here impedance or resistance. So what we're gonna do, so this one, guys, we know that for example, if I give you the impedance or resistance, okay, uh, like for example, if this one equal 5, so we know that the voltage here, this is the voltage in the secondary, which equals 30, and this one, the voltage in the secondary equal 30. And if I give you this one, impedance here equal 5, so we know the current equal the voltage over resistance or the impedance. Okay. Okay, guys, this is the voltage in the secondary 30, and the load impedance 5. That means I can know the current which equals 6 amp, okay? Because 30 divided by 5 equals 6. Okay, I also can use the formula, this one. This one, guys, voltage in the primary divided by voltage in the secondary equal the current in the secondary. This one, current in the secondary divided by the current in the primary. Okay, we know this one equal 120, and the other one equal 30. This one ES equal 30, and the current on the secondary, which is this one 6, so 6 amp, and I can know the current in the primary. From this formula, the current in the primary equal 1.5 amp. Okay, and this one, guys, this is the power. The power, we know the power equal, like any power equal voltage times current. Okay, so here he told about a good rule for any type of transformer is that the power must be equal. So we know that the primary is 120 volt times the current, which is 1.5, equal 180. 180 VA is the voltage amperage. Okay. The secondary, if you multiply 30, this one 30 times 6, also equal 180 voltage amp. This is the uh, power, and in the primary you can see equal the power on the secondary. But also sometimes the secondary is less than the primary because there is a dead current, a flex leak, so sometimes it's not the perfect. Uh, thank you so much, guys.